Hi, my name is Aaron Cosenza, and today I'll be discussing and presenting on databases and DBMS software. So, what is a database? A database is an organized collection of data. It is a collection of schemas, tables, queries, reports, views, and other objects. The data are typically organized to model aspects of reality in a way that supports processes requiring information. So a database management system, or DBMS, is a computer software application that interacts with the user, other applications, and the database itself to capture and analyze data. A general-purpose DBMS is designed to allow the definition, creation, querying, updating, administration of databases. Well-known DBMSs include MySQL, MongoDB, SAP HANA, Oracle, and Microsoft SQL Server. A little bit about the history. In 1960, this became kind of the introduction to DBMS and databases, particularly the navigational DBMS. The introduction of the term database coincided with the availability of direct access storage from the mid-1960s and onwards through disks and drums. As computers grew in speed and capability, a number of general-purpose database systems emerged. By the mid-1960s, a number of such systems had come into commercial use. Interest in the standard began to grow, and Charles Bachman, author of one of such product, the IDS, Integrated Data Store, founded the Database Task Group. These applications could find records by one of three methods: the use of primary key, the navigating relationships from one record to another, and scanning all the records in a sequential order. In the 1970s, this was the era of the relational DBMS. Edgar Codd worked at IBM in San Jose, California, in one of the offshoot offices that was primarily involved in the development of hard disk. He wasn't happy with the lack of search facility, and he wrote a number of papers and outlined a new approach to database construction that eventually culminated into a relational model of data for large shared databases. In the 80s and 90s, new computers empowered their users with spreadsheets and database software like DBase. The DBase product was lightweight and easy for any computer user to understand out of the box. The 1990s, along with a rise in object-oriented programming, saw growth in how data in various databases were handled. Programmers and designers began to treat the data in their databases as objects. In the 21st century was the introduction to NoSQL and new SQL systems. NoSQL systems databases are often very fast and do not require fixed table schemas and avoid joined operations by storing denormalized data and are designed to scale horizontally. The most popular NoSQL systems include MongoDB, Apache, and Cassandra, which are all open source software products. The NewSQL database is a class of modern relational databases that aim to provide the same scalable performance of NoSQL systems for online transaction processing, while it's still using SQL and maintaining the ACID guarantees of a traditional database system. So some examples. So my first example would be the Microsoft SQL Server. This server is a relational database management system developed by Microsoft. As a database server, it is a software product with the primary function of storing and retrieving data as requested by other software applications, which may run on either the same computer or another computer across a network. My second example would be Oracle, or Oracle Database, RDBMS. It is an object relational database founded in the 21st century management system produced and marketed by Oracle Corporation, which is one of the largest database systems known today. So for databases, there are 3 levels of management, which can be seen through 3 different views: the external view, conceptual, and internal views. The external level defines how each group of end users sees the organization of data in the database. The conceptual level unifies the various external views and provides synthesis of all external views. This is the most interesting view to database administrators. The internal level is the internal organization of data inside of a DBMS. It is mainly concerned with cost, performance, and scalability. So database languages are special purpose languages which do one or more of the following. They define data types and the relationships among them, perform tasks such as inserting, updating, or deleting data occurrences, or allow searching for information and computing derived information. So an example would be SQL. This combines the roles of data definition, data manipulation, and query in a single language. It is one of the first commercial languages for the relational model, although it departs in some respects from the relational model as described by Codd. So the database model is a type of data model that determines the logical structure of a database and fundamentally determines in which manner data can be stored, organized, and manipulated. The most popular example of a database model is the relational model, or the SQL approximation, which uses a table-based format, which I have given below in my image. So thank you for watching this presentation. I hope you learned a bit more about what databases do and why they are important. If you have any questions, leave a comment below. Thank you.